PCB design and implementation of clipper circuit. This is experiment number 6 in PCB Lab engineering design subject. Okay, here first before going to the lab circuits, first we have to understand what is clipping, what is clipper circuit. Clipper here means here cutting some portion or cutting or removing some part or on a side of the signal, maybe positive side or negative side of the signal. Generally here we are giving an input of sinusoidal to the circuit, and we are clipping off either positive side signal or negative side signal, or we are removing with some portion of the signal, maybe 5 volts or some part of the signal we are removing on either side or both sides, up to you. So clipper, this is the definition of the clipper, means removing some portion, removing, we can say, clipper. So here if you see the diagrams, we have 7 diagrams, that is 1 2 3 4 5 6 7 diagrams we have here. So each diagram will do different tasks, and the first diagram what we are having is positive series clipper and positive shunt clipper. So series clipper, here name, series means here name comes with the series, means when a diode is coming in the horizontal way, that is in series. Now the diode what is doing, it is based upon its orientation. The orientation means maybe the forward bias or reverse bias. Here the orientation is reverse bias. When it is reverse biased, the input signal what we are sending, positive half cycle and negative half cycle, it will not allow the positive half cycle, it will only allow the negative half cycle. So in the output you will get only negative cycles. Positive cycles will be clipped off, means cut, removed. That is same thing. What is the positive? That's why the name come positive. Positive series. So diode is kept as a series. That's why it is series. Positive means it is removing what item? That is positive item. Same thing, another fashion we have positive shunt clipper. So shunt means when it is connected in the vertical manner, it is called shunt. So the shunt clipper here you can see in the vertical manner, in the forward biased, if it is there, then it will allow for the load resistance negative cycles, and positive it is clipped off, same like the previous one. So here also positive is clipped off, means deleted. So the names indicates the exact output feature, output nature. So positive series clipper and positive shunt clipper are there. Now coming to the negative side. So negative series clipper and negative shunt clipper are opposite to the previous one, where the diode orientation is forward bias in the series negative clipper, that is only negative half cycles or negative cycles are deleted and positive cycles kept are allowed. Here also negative shunt clipper, the diode is here in this fashion, and here also same, positive cycles are allowed and negative cycles are clipped. So this is about the negative series and negative shunt clipper. Now coming to the some part of the clipping, not the complete half cycle, some part. Here if I keep in the biased negative clipper, if I keep in the shunt diode, if I keep one battery in this fashion, then what happens, whatever the battery voltage you are allowing, let us take we have 12 volts here, signal generator sinusoidal voltage. Now if I am allowing 2 volts as a battery, then it will allow up to 2 volts in the negative only. Otherwise if I keep, if I remove this battery here and if I put the battery voltage 0, then the negative portion of the waveform is deleted. So that's why it is a negative clipper. What is a negative clipper means? Negative part is deleted. So actually it has to delete the negative part, but when I keeping some battery in series, this the diode, then whatever voltage we are putting to the diode, that much voltage it will allow, the remaining portion it will be deleted. Okay, so now if I keep, one problem comes when I keep battery voltage more than the signal voltage, that is the more than the signal generator voltage, that is more than 12 volts. Let us take, I am keeping here 12 or more than the 12 volts for the battery, then there is no clipping on the output waveform, because it is allowing complete voltage what the battery is there, or maximum up to what the signal generator is supplying, 12 volts. So more than this it can allow. There is no clipping option there. So that's why we have to be careful. The battery voltage should be always less than the signal generator or wave input signal voltage. So then only we can see the clipping effect in the output waveform. Same if you go for the positive clipper, then positive side you have to clip some of the voltage. Same fashion, the diode is in this orientation and battery is reversed here. Now same rule, if you give the less than the input signal voltage to the battery, then some portion of whatever the battery voltage is there, that much it will be available. The remaining portion is clipped off, means removed, it is deleted. So this is the biased positive clipper, means we are putting some bias, some voltage we are adding, we can say. That's why it is called biased. Now combinational, previously we studied about the bias negative and biased positive. Now if I both together, if you add bias negative and positive, then it is called combinational clipper. So in the as per previous circuit, two circuits I clubbed here. Means one diode, one battery, another diode, another battery with orientation, with these orientations. So what happens? It will delete positive side and negative side both based upon the battery voltage. If the battery voltage is more than the input signal, there is no clipping off. It input will be same as output. Output will be same as input. But if the battery voltage is less than the signal voltage, that is input signal voltage, then that much voltage it will allow whatever the battery voltage you are giving, and remaining part is clipped off. So this we will study in two or three examples I will make. In that you can study that one, how the effect is coming out. So already I draw the circuit. Step by step I will draw a circuit and I will show to you. For this I need some items. For that, so I will write here what are the items we need, so that it is easy for you to. Okay, I can move this here. Okay, first item is terminal, we can name it terminal. The second one is signal gen. Then we need terminal, we need signal gen, we need resistor default 1k you can take. Next we need diode 1N4007, this is the diode, and we need ground. Then for circuit number 5, 6 and 7 we need battery. So let's see how what are the items we can have it. Yeah, I'm keeping this here so that easy to understand. Okay, now let's start. First we need search terminal. Now there are many terminals are there, only we have to use the first one. Don't use A, B, C, D, E, F, just general terminal we need, so that we can name it in the circuit. So when you place it here, you can rotate by right click, then you can place this one and place with terminal name A1. Same thing, place the second one with A2. You can rotate if you want with the right click, and you can rotate this. Next place, rotate here B1, rotate two times. Yeah, next we can place here, yeah, B2, right, B2. Same name should not be there for each terminal, otherwise the system will not will be in confusion state. So this A1, B1, A2, B2 I put it like our circuit here. A1, A2, B1, B2. Now we need a signal gen, we need a resistor, and we need a ground. So here now I need first Let's take diode 1N4007. Just place this diode by rotating in reverse fashion. This is in reverse best. We can keep it here. Now I need a resistor. Search it here. This is the resistor, and this you place it here in the rotation manner. Default 1K you can take, no problem. Now last item is ground for our circuit 1. Place it here. Everything finish. Oh, one thing we missed, signal gen. Signal gen is now is there. Just place this here. Yeah, now our job was save this one with the name somewhere with circuit 1, because we need 7 circuits, so we can keep it circuit 1. Now just take the plus symbol and add one by one component. This is first one we added here. This already practiced how to add and where to add in previous experiments. Now step by step I'm adding this. You can add this also here, and this is here. Like this you have to add. Don't add at the corners between. If you add, it is better like this. See the procedures, it is very important. And this now our circuit is complete, so you can save it. Now use this one. All are set. Now for making the first we'll write some here. This is, what is the name of this? Positive series clipper. Yeah, this is positive series clipper. It's not fitting, then you have to increase it. Series clipper. Yeah, then this one is ready. If you want, you can make the fonts big and small like this. Bold you can increase to 20, no problem. See, positive series clipper. Yeah, now make it fit into the window. This is the one. Zoom to fit to the window. Yeah, so it is fit. Now in this we have to change what some items, that is called this signal gen value. It should be 12 volts, and it should be, let us take 60 hertz, 50 hertz, no problem. You can take anything. 50 hertz, there should not be in kilo, that much high frequency that this circuit cannot hold, cannot give the output, proper output. So 50 hertz should be there, small value, less than 100 hertz you can keep. So now everything is ready. Now here we have to see the output. So to see the input and output waveforms, there is a probe tool. This is called probe tool. We can keep one here. For keeping both sides input output at a time, we need a shift button to press continuously. Press continuously here and here. So both are there. If you are not pressing the shift button continuously, then it will delete the previous one. Wherever you are placing, that will be activated. First will be deleted. So be careful. Use shift button continuously to be pressed. Then place here wherever you want. Now you can take the arrow tool, save it. Now see the output waveforms. Yeah, here again you can use this one to make zoom this one. I think I need one more time to make shift button and use the waveforms. Just you have to keep on the silk. Yeah, now see there is a result. Now the green waveform, the green line with the green color, it is input waveform, which is a purely sinusoidal, and the yellow one where we kept out as a output after the resistor, where resistor is nothing but your load resistor here. So here we are clipping off the positive cycle, we are keeping the negative cycle. We are clipping off positive cycle and we are keeping the negative cycle. It is done by the diode, so that's why it is called positive. The diode is in series, so positive series clipper. So it is the method how to clip off the some or one side of the waveform. Okay, so same fashion we can go negative series clipper, and we can do very fast manner by saving with as a save as. You can keep circuit number 3, because 1 and 3 are almost same, with only the orientation of the diode is changed. I will delete this diode and I will keep a new diode here with different orientation. It was in reverse bias, I will keep in the forward bias, so that it will save your time. 1N4007, very fast. So previously it was reverse bias, now I will keep in forward bias. Yes, now I have to change this negative. No, yeah, negative clipper. Okay, negative. No, we have to make a bigger one so that all items should become, because it is in again. Series negative series clipper, so it is there. Okay, so negative series clipper here, that is called, only we are removing the negative part, we are allowing positive part. So just save this and see the output. Yeah, we are removing the negative part and we are allowing the positive part. The green one is the input signal and yellow one is the output signal, where negative side is removed or clipped off, positive side is allowed. Okay, so this is experiment number circuit number 2. Now we'll go to the uh, positive. Okay, positive shunt clipper. Let's take shunt clipper. Now I have to save this one first. Save as. Now circuit number 2. Now you can see here what is the this one. We have to keep a resistor here instead of diode, and the diode should be in the shunt manner, in the vertical manner, in parallel to the RL resistor. So you can rename this with RL so that you will not be confused. Now remove this by using delete button. Now I can remove this line, this and this, so that it will be easy for you to understand. So what I need first, IN4007, I got it. It should be rotated upward or downward. Just check. It should be downward. So rotate downward. Now you can connect here. Now I need a resistor. So there is a resistor and place this. Now use the wire tool to connect all the items. Now while we are connecting this, you can see there is no dot like here. There is no dot like here, means there is no connection. Later I will make the connection. Be careful when I removing the wire and we are connecting. You must check that all connections are perfect. Here then you use the arrow tool. So all the dots are here, means these are connected. These are connected. Only here this is not connected. Now you can move this wire like this, then it is connected. Now you can save this one and you can run. And before that I will keep the probe here. 1 and 2. So okay, arrow tool. Now you can this one and make the this one. Now check here, AB already there. So here you can see in the shunt means in the vertical manner. Positive means we are removing the positive output signal. See, input is there, output is not there. Negative, we are keeping it, because we are having two different resistance here. The value of the maximum voltage or voltage is less than the input signal, because some part of the voltage is dropped in this series resistance. Okay, without this resistance the circuit will not come, it will act as a short circuit. So be careful. Don't do that one. Keep some resistance in series. You can keep the value of the resistance very small, no problem, but there should be some resistance. So this is your positive shunt clipper. Now then we will save this as the other one to make it negative shunt clipper. So save as circuit number, you can have 1 2 3. Now this will be 4, circuit number 4. Now what we are doing, just we are removing this diode and we are making in the reverse panel 1N4007. So place this one in the rotatable manner upwards. Just add this. Yeah, it is connected. Only you have to change this one. So shunt this is, but it is negative. Negative shunt clipper. Okay, now save this. Now check the output. Same. Yeah. Now negative shunt clipper means we have removed the negative portion. Previously we removed the positive. Now we are removing negative. So it's like same like the previous fashion, but the portion of the clipping is different here. Okay, because of the diode orientation, forward bias and reverse bias. Okay, this is the circuit number 4. Now 3 circuits are left out, and that's the is given by here. We can go to the circuit number 5. We can save it, save as circuit number 5. You can save. Now in this, what is the circuit? You can check here. Circuit number 5, negative series we finished, negative shunt we finished, biased negative clipper. Positive also you can do, but now here we has negative biased only we will do, because bias is like a negative side or positive side. Okay, so bias negative clipper, we are putting a battery in series with the diode. So then we have to remove this diode first and remove this one. Now what do we need? Diode we need, one battery we need, diode and battery. So search and diode and is in upward fashion, and one battery in reverse fashion. So battery, if your battery is in the opposite fashion what it is showing, then it will be problem. That is, you are allowing to the positive side, not the negative side. So you can have big size, you can understand easily. So negative, it should be rotated when you are using the positive biased. So now you can have this one, you can add. Now here it is biased shunt, you have to remove biased negative clipper. Okay, this is done. Bias negative clipper. Now battery we connected. I told you be careful for giving the voltage to the battery. It should be less than the input voltage. Input voltage is 12, so it is less, but further less it is good, because already some voltage is dropped in the resistor. So my point is, you have to be, to understand easily, you must have very less voltage. Let's say 2 volts, not more than that one. So 2 volts is the battery voltage. Now input and output probe, so I already connected like previous one, nothing I changed. So this is bias negative clipper. Now check the output waveform. See here. So what you are observing here? Now we'll check this. Yeah, here I am observing positive side, nothing is clipping off. Positive cycle, positive cycle, positive cycle is there in the output. Negative cycle, when you see the negative cycle, as per the negative shunt clipper, it has to remove complete negative cycle. But I am telling biased negative shunt clipper, I can say. So the battery effect is coming here, means it is allowing the battery voltage, then remaining portion is removed. See how much is the battery voltage? 2, but it is keeping 2.5. Why? Because the diode have cut-in voltage, germanium and silicon, two types of diodes we have. So silicon is zero point 0.6 and germanium is zero point 0.8. So that zero point 0.6 voltage plus this 2 volts, it is added up and remaining portion is deleted. So the system is taking a silicon diode which have cut-in voltage of 0.6 volts. So that zero point 0.6 plus the battery voltage 2. So 2.5, 2.6 it will be there. 2.6 is actually. So remaining it is clipped off. Okay. So this is your bias negative clipper. Now let us take the reverse one. Now you can save this as a sixth, save as 6. Only one circuit left, don't worry, I will make it fast. Okay, now remove this. What we have to do is just we have to remove the silk, the wire, so that when we are rotating it, it should not be a problem. Oh, control set. Yeah, now rotate this. Both you have to rotate. Now rotate this. Same thing I am keeping the voltage of the battery and everything. You can connect now. Yeah, so I finished connection. You can rearrange this one. Okay, anything you can do it, no problem. So now I change the value to biased positive clipper. Positive clipper, biased positive. Now, okay, yeah, bigger size. Everything is same. This is diode is orientation change and battery orientation is changed. Now check the output. See here, biased positive clipper. Here, see, negative side, no clipping. Negative cycle is as it is, no change. Only in positive side, I am clipping off the cycle. But due to the battery 2 volts and the silicon diode 2.6 volts, 2.6 volts is allowed and remaining part is clipped off. So this is the way how to do the clipping for different circuits. Now both sides I want to clip some portion, not the complete half cycle. Then we can see it by changing or adding something. Now save as this circuit as 7 so that you can understand easily. All circuit will be saved. Okay, now make it big. Now what I have to add? Battery and diode. So place the battery here, rotate here. Next and 1N4007 diode. Place this here and this should be rotated up. Okay. Another way you can do like this. You can join and you can join this battery. You can keep like this. Okay, battery also you can join like this. Means without using the wire, you can do in the simple fashion. Now this is combinational clipper. Combinational, there won't be any series or the positive or negative because both sides it is clipping off. Combinational clipper. Okay, so you can save this and you can make it big. Now you can have this. Okay, one thing we forgot, change the battery voltage to 2 volts. Now everything is done. Yeah, now go to execute, means run the simulation. Now you can again check here. Yeah, this is the circuit. Now check here, positive side some portion is clipped off, negative side some portion is clipped off, that is more than the battery voltage and cut-in voltage, diode cut-in voltage, that is 2.5, 2.6, we can say 2.6 here, 2.6 here in positive and negative side is allowed, remaining portion is clipped off. So this is your combinational clipper. Okay, so this completes your experiment number 7, clipper circuit. I hope you understand and enjoy the uh, lab. So PCB design implementation of clipper circuit is finished. So the circuit maker is the software what we used here. Okay, thank you for watching and thank you for listening and practice it in your personal computer or in your laptop in this software Circuit Maker 2000, which is provided to through your blackboard. Install it and practice it. Thank you.